Hare Krishna. Hope you are doing well. Let's get started with this question on system of linear equations. We are given a system which is anchoring on two special variables a, b, and based on the values that these can take, we have to check how many possibilities are there for unique solution, no solution, and finite solution, and a specific particular case as well. Let's get started. Now, we see that there are in total five variables over here a, b, x, y, z. But the way system of equation works, it's like we are focused on x, y, z as the variables for which the values have to be found. So they are isolated, and a and b are a part of the coefficient matrix. These are our variables of concern. Now you may notice that the original structure which was given is slightly tweaked over here. The reason we'll see in a moment is to facilitate quick computation to come to a reduced row echelon form. By that I mean by elementary row operations converting this structure into a triangular matrix where like these parts become zero. Okay, it may seem a lot to take, but let's start step by step. So this is just represented like this for faster writing. Then what we do is the motivation is to make this zero, this zero, this zero. So we start with taking the use of this row to make the elements over here and here zero. So we modify row 2, new row 2 to be row 2 minus 4 by 3 times row 1, because this would ensure that this thing becomes zero, and every other element we do the corresponding multiplication with the above row 1, and row 3, the new row 3 becomes row 3 minus 1 by 3 times row 1. Why? Because that is how element at this position will become 0, and everything else gets a similar computation. So we now have this form. Now to make this 0, we have to again just row 3 minus 5 by 3 times a minus 4 by 3 row 2, because this is how this element over here will become 0 provided a is not equal to 4 by 3. Because if a is equal to 4 by 3, this thing becomes 0 here itself, and it is similar to just swapping these two rows so that this comes down, and then we can adjust these two to make this position 0 as well, and we would have the form. And when that happens, we can say that regardless of the value of b, which means b is free to take any value, infinite choice of values for b, this matrix over here will be a full rank matrix, and that would be giving a unique solution. Okay, now let's also see the intuition behind how this kind of structure helps. So the motivation to come to a matrix of say this form where these positions are 0, and then we multiply with the variables for which we have to find values, and we have some constant on the other side, is to see that once we have this form, it becomes very easy to find the value of the last variable. Z is basically C3 by uh, divided by A33. Uh, and with the value of Z, it becomes easier to find the value of Y. And with the value of Y and Z, it becomes easy to find the value of X. So this is why we reduce the system of equation or transform it into this structure. So a equals to 4 by 3 gives scope to take infinite values for b to get unique solution. When now a is not equal to 4 by 3, when we look at this thing, it will become 0. So what matters is this and this. Again, there will be infinite solution if this is 0 and this is 0. The intuitive way to understand is, when this entire row becomes 0, it is like you have three variables x, y, z, but only two constraints on them coming from two rows. So there's like this one degree of freedom which is allowing scope to take a lot of values. So that is why infinite solution, less constraint, so infinite possibilities to explore for solution. No solution when this is 0 and this is not 0. Again, the intuition to understand it is that if you have this part becoming 0, it is like essentially saying 0 times x plus 0 times y plus 0 times z is equal to some quantity which is not equal to 0, non-zero quantity. How is that possible? This is not possible. So it's an inconsistency. That is why this kind of condition brings a no solution, and unique solution when this particular part is not equal to 0, because then we have essentially three variables with three constraints on them, and the universe balances out, so to speak, and for each variable there is one particular value only to take, so the solution is unique. And this is the intuition behind why we get infinite solution, why no solution, and why unique solution when we reduce the matrix structure to a reduced row echelon form. And now let's see, infinite solutions, sorry, unique solutions, infinite ways to go there, because when a is 4 by 3, whatever value of b we take, it would be unique. The solution for xyz would be unique. When when we talk about infinite solutions, essentially we see that we have two equations over here and two variables a and b, and hence we see that two equations, two variables, so both sort of come together and give only one particular value for the variable a and b, which is why there's just finitely many solution for which this is holding. So this is correct. Oh, this one was incorrect. And for no solution, again we have, it's like this, we have one constraint over here, and this is in a sense also a constraint, but the way it is put over here, there is infinite choice for a to take. It just doesn't have to become 0, but there are infinite other choices for it to take, based on which b can take a fixed value. So again, there is some freedom to choose values, so this is also incorrect. And for a equal to b equal to 1, we can see that this condition which needs to be satisfied for a no solution, this is not checking out, so this is incorrect. So only option c is correct. Again, maybe this was very extensive and too much, but on purpose, because this structure is what is usually followed to solve this kind of system of linear equation question. You reduce to row echelon form and you see these last two terms, how they are playing out, and you come to whether the solution is infinite, no solution, or unique solution. Take care. Hare Krishna.